was preparing this lesson. So
the direct variation and the piecewise, I think, were like the two new things.
I don't even think that direct variation.
It's not really new, but it's like, it's the wording.
Yeah, and I was trying to remember if we actually still do direct variation.
Notes.
Yeah, but it's not on the, it's not, well, it's not on the main homework, and I will check the last test. It wasn't on the last test, so I'm like, I don't know.
Yeah, if they take like physics or anything, it'll come up.
Oh yeah, I mean, it's
Ring
important.
constants.
It's definitely important. It's just.
I thought we did indirect, and I thought we did inverse when we did irrational functions.
You know what? I just need to remember, because I thought that they were off, so that may be something we need to cover.
Yeah, it might have been something they removed, because I know they removed quite a bit too.
Yeah. It's like I forget from year to year or from semester to semester. Okay, just a second. Where are we?
I do have all the tests though, so.
Oh, that's awesome. Well, good. I know. Okay, and we'll talk right after class as soon as I can get this stuff. There's my slide. There we go. I lose my window and I can't get it back. No. Okay. Okay, I'm just going to go ahead and start. Sorry about that, guys. I have lost the ability to do the actual Pear Deck, so I don't know where it went. So we're just going to go through the slides, which will be fine. Just this is going to be the homework is going to be attached to this as well. So just kind of if you'll follow along, and we'll talk through it. And it's irritating to me because I spent a lot of time doing this and now I can't find how to bring it up. Oh well. Okay. All right, so these are the things that you should have gained from watching Matthew's videos. You should be able to find a formula for a function using function notation. Really, we've already done that. So use functions to model applications. We've already done that. Be able to graph and understand the meaning of piecewise functions. Be able, and we'll talk, that is new. And understand whether a function is continuous or discontinuous. And that is new. And I was under the impression that we were not supposed to do direct variation. So we may need to go back and put that in, but because it was in the notes, but then I looked at the old tests and it wasn't on the test and it wasn't in the homework. So anyway, all right. So the first thing I want to talk about is okay.
It looks like you're logged in as a student. I don't know if that makes a difference.
You know what? Maybe I can. Okay, yeah. Let me try to get out of that and see if that will help me. Thank you. I just feel like it just went away on me for some reason. I do not know why. I might have clicked off of it accidentally or something, but it's not coming back. So, okay, here we go. Right. All right, so the first thing, so you don't worry about doing this. I have to figure out what went wrong, which is really annoying because I had some fun stuff going on here, but never mind. One of the functions that I like, that I believe that Matthew went over, is the step function, or the greatest integer function, and that's the one that looks like steps. And I always like to think of it like people as they age. Like when you're born, you're 0 years old, and then you're 0 years old until you get to be 1 year old, and then you jump up to 1, and then you're 1 year old until you get to be 2 years old, and then you're 2 years old until you get to be 3 years old. So that's how the greatest integer function works. It is actually the rounding down function, but it always looks like steps, and it's an interesting function. And I believe that we will be doing some transformations with that function, even though you don't see it in this lesson.
Unless you're one of those annoying kids, it's like, I'm 6 3/4 years old or something like that, right?
Yeah. Well, yeah. I know. It's like, right. Okay, so I wanted to, before we start the homework, I wanted to first go through piecewise functions real quick, because I wanted to make sure that y'all are very comfortable with this, and then we'll kind of go through this together. But so they kind of look intimidating. So first of all, I want to make sure that you know, like, what is f of -2? So you look at these intervals, each one of these intervals. If your x that you're given x is between -3 and -1, you're going to use this formula. If the x they give you is between -1 and 2, you're going to use this formula. And if it's between 2 and 5, you're going to use this formula. So f of -2, somebody tell me which formula would you plug the -2 in for?
The first one.
That's right, because -2 is between -3 and -1. So f of -2 would be -2 minus 1, which is -3. Okay, and then what about f of -1? Where would you plug that in?
Second one.
Okay, so this is where it gets a little bit interesting, because notice that these are equals, right? So that means that the -1 falls in that interval. Does that make sense, what I just said? Because here there is no equal symbol. So that means that it goes from -1 to 2, but it actually, that second interval doesn't include the -1. So f of -1 would also go into the first inequality. That inequality would also, that number would also go into this first equation. And so we'd have -1 minus 1 equals -2. All right, what about f of 2? Where would it go?
Not the last one.
The last one, right? No, it wouldn't go in the last one, because look, here's anywhere there's an equal symbol, that's where it's going to go. So it goes.
But it's positive. It doesn't matter if it's positive or not.
Oh. Because the number 2 is going to be in this interval, right? Because it's between -1 and 2 and inclusive. So f of 2 is going to be in this interval, which is just 2, the number 2. Okay, so when we graph these things, I'm just going to do a little T-chart. And these are linear. The ones y'all are going to be doing are linear. So they're pretty easy to do. So I'm going to put -3 and -1. And because there's equal symbols, they're going to have solid dots. And so -3 minus 1 is -4. And -1 minus 1 is -2. So that's going to be the first little section that I'm going to draw from -3, -4, to -1, -2. Just that little piece. Then I'm going to look at this next piece. Oops. And so I have x and my f of x. And I'm going from -1 to 2. And notice here, the inequality symbol that's next to the -1, it doesn't have the equal symbol. So that would be an open dot. But the 2 would be a closed dot. And everywhere in that interval, the f of x is just 2 because it's constant. So -1, 2, we have an open dot, and 2, 2. So it's just that little piece right there. And then finally, I'm going to look at the third piece. And it goes from 2 to 5. Notice the 2 will have what kind of dot on it?
I said it's solid. The
Okay, so,
one that, no, the one that's like a dot.
yeah, open. It's going to have an open dot, right? Okay. And then what about the 5?
The one that's filled in.
That's closed dot, right? So I'm going to have, so 3 minus 2 is 1, and 3 minus 5 is -2. So 2, 1. And then 5, -2. So there's my third piece. All right, so the question here is this graph continuous? And it's really easy to know if it's continuous. If you can draw that without picking up your pencil, then it's continuous. But obviously this one is discontinuous because there's no way I can draw this without picking up my pencil. Okay, so then this one, number 43, is the homework. Is on the homework.
So in that previous one, it might be like worth noting, like when we plug in or evaluate like f of a minus 1, we're doing the solid dot. Like we do plug it in for that open dot, but we don't actually use that quantity. That point, like it's an open dot, it's not actually there.
Right. It goes all the way up to there. It goes all the way up to like, it'll be like 2.9999999, but it won't be on the 2.
And so if we're looking graphically at like x equals a minus 1 or something like that, we see that one that's open, it's like up there, but the one that we really want to go to is the one that's like down there.
That's exactly right. And if they had 2 solid dots, okay, so this one they were both solid on. If you had a solid dot here, it wouldn't even be a function because remember, it wouldn't pass the vertical line test. So you've got to have, if they're the points are overlapping, one of them has to be open or it's not a function. All right, so let's look at 43, and this is where you need to be writing because, and I want to make sure we got through these first, even though these are at the bottom of the homework. So determine the domain. What I like to do first before, even though they said that is part A, I actually like to kind of see what the graph looks like first. So that's what I'm going to do. I'm going to graph it first. So this is going to be the first thing I do. So I'm going to do x and f of x. And I'm doing this piece first. So what numbers am I going to put in for x here? I'm gonna start calling on people.
-2.
Okay, thank you, Gabriella. -2 and what else? And 1. And what kind of dots are going to be on there?
There's going to be the filled in dots.
That's right, the filled in dots, exactly. All right, so 2 times -2 would be -4, and 2 times 1 would be 2. So 2 points on this graph are -2, -4, and 1, 2. And those are both filled in. Okay, so now I'm going to do the second piece. And Hunter, will you help me do this second piece, please? What numbers am I going to fill in? What numbers am I going to put for the second piece?
1 and 2.
1 and 2. And what kind of dot is going to be on the 1?
Open dot.
Open. And on the 2?
Filled in.
Filled in. And what's the y values going to be with those x values? Or what is the f of x going to be?
2.
Just 2. Because it's this constant right here. So I have 1, 2. And that's an open dot. And then 2, 2. Like that. All right, so is this continuous?
Yes.
Yeah, it is, right, because actually this is filled in, right? It's not filled in on this interval here, but it is filled in on this one. So this one is continuous. You could draw it without picking up your pencil. All right, so now let's evaluate f of -2. So what is f of -2? We already said it was -4. And then what about f of 0? You could look at the graph and find it, right? What is f of 0?
0.
0, right. You could either fill it in here or look at the graph. There it is, right? So f of 0 is 0. And then f of 3? I know I'm sticking with you on this one. What's f of 3?
Okay. For that one, is it gonna be 2?
All right. Hunter, what do
I
you think?
still get confused on how do I know to which equation I use. Either the 2x or the 2.
Well, okay, so if your number is a -2, a -1, a 0, or a 1, or any fraction that's in there would work too, but we're probably not going to give you fractions, you would go here. Because that says x is between -2 and 1. If your number, okay, if your number, now one is not
3 is
included
outside
here.
the range of both
Yeah.
functions.
Yes, and 3 is totally not even there. So f of 3 is not on the graph. Okay.
I would say it's undefined is the word that I would use. Because we have our function definition, it's defined that way, and it's not in the definition of the function, so it's undefined.
All right, so we're going to want to talk about the domain. So what is the domain here? What's the domain? Hunter, what's the domain?
-2 to 2.
Yep. And what's the range?
-4 and 2.
-4 to 2, right? Okay. So this one's also on here. So let's look at each piece. And Timothy, will you help me with this one? What numbers am I going to put in the first piece?
-3 and -1.
And what kind of dots?
Going to be closed.
Closed, good. And what's going to be my f of x? What's the y values?
I really don't know, to be honest.
Okay. So this says
twice already. This is still not making sense to me.
Okay, if x is between -3 and -1,
Right.
then f of x is just that number.
So
Maybe it'd help if you'd say like f of x equals x, like right up above there.
It's gonna be -3.
And what else?
And then -1.
Perfect. All right, then. Okay, so Timothy, do you see why those two numbers are -3 and -1?
No, I just.
Okay, all right, so this says that f of x is just equal to x. So that means that whatever the x value is, that is what your f of x value is as well.
Take a little more practice to get used to that, but yeah, I understand why.
Okay. All right, so let me ask you this. If you have x, and now I'm looking at the second graph in f of x,
All right.
what two numbers am I going to use?
-1 and 1.
And what kind of dots?
Open.
Open. Now this says that f of x equals to 1. So what is going to be my f of x in this case, always?
-1.
Just one, right? It's always going to be 1.
Okay.
No matter what, okay?
All right.
Now I'm looking at the third piece. What numbers am I going to use?
1 and 3.
1 and 3, and what kind of dots?
Closed.
Closed. And then 2 minus 1 would be
1.
1, and 2 minus 3 would be
-1.
-1. Okay, so now I'm going to graph these things. So here, -3, close dot, -1, close dot. And then the second piece is -1, 1, and that's an open dot, and 1, 1. Oops, -1, 1, and 1, 1. They're both open dots. And then finally, 1, 1, and 3, -1. Okay, so that's what this thing looks like. Is this continuous or discontinuous?
Discontinuous.
Absolutely. What is the domain?
Let's see. -3
Uh-huh.
to 3.
Yep. And the range?
-3 to 1.
Yeah. Awesome.
You dropped a negative sign on that domain.
What did
Sorry?
I do?
On the domain, it should be -3 to 3.
Oh, thanks.
Gonna need a little more practice to get the hang of it, but yeah, it's starting to make sense.
Yeah, it will. I honestly, it really does take some practice. So, okay, so let's do 53. And I would like, Michael, can you help me with it?
Okay, I'm really struggling here, so you have to forgive me.
Oh, don't worry. Don't worry. No. Okay, so what's the first, what is the first chart going to look like?
Like if it's an XY chart?
Uh-huh.
Or XFX?
So what are you going to put in for X on that first, for the first interval?
So if we're just doing a chart, I guess it would be -5 with a closed dot.
Yep. And what else?
And 1 with, and 1.
With what kind of dot?
Well, that would be open.
Yes. All right, so if you plug in -5, what are you going to get?
Okay, give me 1 second here.
Sure.
Let's see. So this is if F is, or X is equal to 23, correct?
So if your X is -5, what would your F of X? Or your
Oh,
Y?
sorry, I was looking at part A here.
Okay.
So if X is equal to -5, that would be -14,
Okay.
or no,
so
-16.
there we go. Thank you. Yeah, -16. And then what about if X is equal to 1?
That would be +2.
Yes. Okay, so +2. So we've taken care of the first interval. So now let's go to the second interval. Okay, what X values are we going to use?
So 1 with a closed dot.
Yep.
And 3 with a closed dot.
Yep. And what's the F of X?
Let's see here.
It's always
Well, I
gonna be,
mean, I guess that's just 4.
yeah, that's right.
And then the other one would be 12.
No, it's still 4, right? Because in this interval, no matter what number you pick in that interval, it's going to be 4. Because f of x equals 4. It's like it's a horizontal line, constant.
Oh,
Does that make sense?
okay.
Okay, because there's no variable attached to that 4. So no matter what number you pick between 1 and 3, it's going to be 4. Okay. All right, and then finally, this last interval, what numbers?
Let's see here. 3 open dot
Yep.
and 5 closed dot.
Yep.
Okay, so if it's 3, then that's gonna be 3.
Yep.
And then if it's 5, that's gonna be 1.
Yep. All right, so now let's graph these.
I think that, yeah, the last piece of paper had the graph. Yeah, there we go.
Okay, so -5, 1, 4, 5. -16 is going to be way down here. And then 1, 2. And that is an open dot. And then 1, 4. And 3, 4. Both of those are closed dots. And then 3, 3. And 5, 1. Okay, so that's what the graph's going to look like. And so is that continuous?
No, discontinuous.
Right.
I was gonna say, like, after they graph this, like, they might want to take a step back and look at those equations. They know, like, what each of those equations should look like. That first thing should look like a line going up. That second part should look like a horizontal line. It's a constant function. That last part has a negative slope. It should look like a line going down, right?
Yeah, think about what you're doing for sure. And so what is f of 23?
None.
Okay, but like Matthew said, we really, this is what I do because I think I'm being funny, but really you should say it's undefined, okay?
Undefined. Okay.
Yeah. And so what about f of 1? Michael, what do you think?
F1.
F of 1.
Okay, so if it's f of 1, let's see here.
2.
Isn't there multiple values for that?
Okay, that's a good question, but look at the graph. Which one has the open dot and which one has the closed dot?
Okay, so the green line has the open dot. So that one
that's
doesn't
not-
count then?
Right, that doesn't count.
Okay, so we're gonna look at the red one. So that's gonna be 3 then. Or no, wait, 4.
Right. Okay. So if you looked at the charts, you could see that f of 1 is 4, right? All right, and finally, let's see here. What about f of 2? What's f of 2?
That would be 4 again.
F of 2 would be 4, yes. And f of 5?
That
One.
would be 1, yeah.
Yep.
1. Yeah.
Yep. Right. Again, this takes practice, and there is one like this on the homework worksheet, so that's good. So move on for here. This we've already kind of done, but the data in this table lists points on a linear function. What is the slope and what is the y-intercept? So I want y'all to think about that for a minute. And they're telling you it's linear, so you know it is, because otherwise they'd be lying to you, and they can't lie in the directions. Chelsea, did you get the slope? Is Chelsea there?
Do we answer that in the app, or
Is that what?
do we answer it in the app? In the,
Well, I can't see the app because I'm a goofball and somehow I lost it. Yeah, so just answer it.
oh, okay.
Yeah, I don't think Chelsea's here today.
Okay. Who else?
Is it A? Oh, I'm sorry.
Okay, so how do you find the slope here?
You subtract 3 and then 4. And
Okay.
then 1 and 3.
Okay, so you don't have to do the points here are -2, 4, 0, 3, and 4, 1, right? And they tell you this is linear. So you don't have to prove it. So you really just have to pick 2 points to find the slope. So I picked these 2 points because you already started with them. So I'd say 3 minus 4, what would go on the bottom?
Zero and negative parentheses -2.
Right. So that's going to give me -1 over
2.
right. Okay. So our slope is -1/2. And what's the y-intercept?
3.
3.
0, 3, right. It's going to be 0, 3. So the y-intercept is 0, 3. B equals 3. That's the point. Okay, so can we write an equation of a line if we know the slope and the y-intercept?
Yeah.
What is it?
-1 over 2 x plus 3.
Yep.
Okay.
Okay. Now, if they had not given you the y-intercept, what would you have had to do to write the equation of this line?
You would have to find. Would you have to do the what's it called? The y minus y1, and then the m and the x equals x1.
That's exactly right. So it's really nice when they give you the y-intercept, but if they don't, no biggie. You can figure it out by using the point slope form. Okay. All right, so now moving on to number 7. I know we're kind of going all over the place. Which one of these graphs best models the height of the Empire State Building from the year 1980 to 2010, where the X values represent time? And I'm gonna call on somebody again, because Christopher, are you here? Chris here?
He is here. I don't know.
All right. Elliot, are you here?
Yeah, I'm here.
Okay, so do you have an idea of what the answer to this one would be? So let me ask you, did the height of the Empire State Building change from 1980 to 2010?
No.
Okay,
Oh,
right.
so it'd be D.
Yeah, there you go.
My bad.
No, that's not, no, that's not, you just have to just think about it. Yeah, I mean, unless they're not building on top of the Empire State Building, it's pretty set. Okay.
All right.
Okay, Elliot, can you stay with me here for a minute? Since
Yeah.
I think my apartment's the C one.
they just
It,
keep on.
it is sinking, man. This like my apartment is sinking.
That's terrible. All right, so Elliot, hang with me. Which one of these graphs best models the distance between a runner in a race and the finish line? If you think about what's happening, right, with a runner in a race and the finish line, what's happening there?
I would think that it's probably C
Yeah, right, good. Why do you think that?
because he's trying to get to his destination instead of like running away from it.
So right, as your time increases, you're getting closer and closer to the finish line, right? You're getting close to the finish line. So yes, good. Awesome. Thank you. My number 13, I feel like we've done this kind of problem like to death. So in the first month of 2016, about 0.6 trillion text messages were sent. The number of text messages being sent each month during 2016 grew by 0.08 trillion per month. I'm going to let C be the number of text messages and N be the month. So, August, are you here? Aurora? Is Aurora here?
Yes.
Okay, can you help me with this one?
August is here. Her mic's not working,
Oh, okay.
but she's chatting.
Okay, oh, good. Thank you, August. Okay, look at the chat then. And Aurora, you can chime in here too if you want. Okay, so yeah, my mic. Okay, so August, since you're chatting here, can you tell me what is the C-intercept or the Y-intercept? Or Aurora, can you tell me? Can anyone tell me?
Well, you said the C-intercept?
Uh-huh.
Let me see. C equals the number of text messages, so 0.6 trillion.
0.6 trillion, right. Good. And then what is the slope?
0.08.
Yes. Okay, so what's the formula? Timothy, since you're with me on this.
Guessing from here on out, C equals 0.08.
2016.
Okay, I'm gonna put C of M
Right, forgot the variable.
Equals, tell me again.
I would say 0.08 m
Hmm.
plus 0.6.
Yeah. Right. And then we have to remember that we're talking about trillions of dollars. But that's it.
Really?
Thank you. Okay. So number 19.
Well, real quick, this on 13,
Yeah.
it says in the top caption, it reads, write a form of linear function in that model situation. Choose between an appropriate name and appropriate variable function. State the variable represents the domain of the function. Assume that the domain is the interval of all real numbers. Like, do we still give it a domain for this question, or?
Oh, yeah, I kind of did most of it. I did a lot of that. I chose the variables. I chose C and M. You could have chosen anything. And yeah, so we're through with it. We answered.
Which variable represents the domain?
Which one does?
That's what I asked.
Okay, so the domain. Okay, so if you think about what the domain is, what variable usually represents domain?
Okay, I get it. Yeah, M.
Okay, right. Because M is like our X. And the M is the independent variable. Okay, and the C is what's dependent on that. So yeah.
Thank you very much.
Yeah.
It's usually always the thing you're plugging in,
Mm-hmm.
or the independent variable. Yeah.
Gotta write that down.
Okay, so here we go again. A 300-gallon tank is initially full of water and is being drained at a rate of 10 gallons per minute. Okay, so what
Ms.
would
Watson?
yes.
I'm sorry. Actually, I was wondering. I did try to work this one out, so I guess I volunteered for this problem.
Would you please?
You got it. So for A, I put W parentheses T equals 300 minus 10T.
Great.
All right.
Okay, and then how much water is in the tank after 7 minutes?
So I rewrote the equation, negative 10 parentheses 7 plus 300.
Negative 10 times 7. Okay, plus, okay,
Yeah, I rewrote the equation.
okay. And
And
then,
the result was 230. For the units, I put galleons. So
okay,
gallons. So I wanted to know if that was correct, the units.
that is correct.
Okay, perfect. I don't know if the gallons changes or not. Yeah, I got 230 gallons. And I'm not sure what, C was asking for, graph the function W and identify the intercepts. So for this, for graphing, I had no idea how to graph it or even how to find the intercepts. I do know that 0, 300 probably is the Y.
Absolutely.
I still went on my calculator and graphed 300 minus 10T, and I looked at the table of intercepts and
Okay, so
I got it.
okay, you're really doing well. So we said this is W of T equals 2 T plus 100, and then part 2 was 230 gallons. Okay, so you said you know that the y-intercept is 300 gallons, right?
Right.
Okay, so this is going to be my gallons, and this is going to be down here. What would your
I put minutes.
w-axis, and then and minutes is going to be your time, right?
Right.
Okay, so so we know that the y-intercept is 300. So what would be a good scale for this?
Well, I put for minutes. I put 10.
Okay. Well, okay. So what about the? I'm talking about the w-axis.
Oh, gallons. That's what I mean by here when I started.
Okay, so you're going up to 300, right? So what?
Right.
you wouldn't want to pick ones probably in this case,
No.
right? So pick like 50s.
Sure.
Okay.
Like this is the part where I just
You just have to pick, you can pick whatever you want. It's
so
just
like it
that
can be like any number, really? Like when you're
really you
I thought it was like a
can.
select number.
Yeah, you can, but you want to be able to see some, like if I picked 100s, that would probably not be the best because it wouldn't give me a really good indicator. You could have picked 25s maybe, or it really, you can pick any number that you want. It's just you want to make it fit on the graph, and you want your graph to tell you something, right?
Right.
So here's our 0, 300. We know that's where it starts, right? Now we
Right.
want to know what the y-intercept or the x-intercept or the m-intercept is. We know what is the y value on this axis. What is every single time? What's the y value?
Say again?
Okay, so on the x-axis, what is the y value of all the points on the x-axis?
The minutes.
What is, no, I'm asking what's the number of the
Oh,
y?
like 10.
Zero.
and stuff.
What?
0.
0, right. Every single y value here is a 0, right?
Right.
Okay, so basically what they're asking you to do is plug 0 in for y and see what x is. Or in this case, you're going to plug 0 in for w, right? Because w is like our y values.
Right.
So we're going to say negative 10t plus 300 equals what?
0.
0, right. It's like to find the x-intercept, we plug 0 in for y. To find the y-intercept, we plug 0 in for x, right? Just like we always have been doing. So I'm plugging 0 in for the y value. So I'm going to say that's equal to 0. And then we just solve this problem, and I have negative 10t equals to negative 300. So t is going to equal to 30 minutes. Okay, so my question for you is, what scale would you like to use for your minutes?
I put it by tens.
Okay, well, we could do tens. So we do 10, 20, 30, right? If
Right.
we're doing tens. And so then this would be it. That would be our y-intercept, right?
Mm-hmm.
And then our graph would look like that.
This is gonna take some time to get used to.
What's the domain?
For the domain, I put negative infinity to
Okay, so where, I mean,
like
the domain, we're talking about time, right? And time always
Right.
has to be what?
real numbers.
Yeah, but can it ever be negatives? I mean, unless you're in Back to the Future or something.
Ish, but no.
No, so you have to have, so where does the time start in this? How many minutes at the
10.
start? No,
0.
0, right. It starts, you've got 300 gallons in the tank at 0 minutes, and then it starts draining. And when does it stop draining?
30 minutes.
Yeah, so the domain would be from 0 to 30 minutes. Okay, so this next one says a roof has 0.5-inch layer of ice on it from a previous storm. Another ice storm begins to deposit ice at a rate of 0.25 inches per hour. So can someone tell me how to write the equation for this function?
I guess I'll volunteer again for
Okay.
3. I put f of x
Okay.
equals 0.25x plus 0.5.
Good.
And then for B,
Hmm.
rewrote the equation 0.25
Okay.
parentheses 2.5.
Okay,
I
so
think.
It's
Yeah.
for that one.
So f of 2.5, right? Is
Yeah.
5 times 2
0.25.
plus 0.5, and what is that equal to?
I got 1.125.
1.125 what?
Hours or inches, sorry.
Inches, right, right. Okay.
Oh boy.
Okay, for this graph, what are the maximum and minimum speeds? What's the maximum speed on this graph?
0.60.
So actually, it's just these pieces that we're looking at, right?
Dash.
So what this is saying is when this person is driving from 0 to 4 miles, he's driving 55 miles an hour. And then at 4 to 8 miles of his journey, well, from 4 to looks like to 6, he's driving 40, and then he's driving 30, and then he goes back up. Do you see what's happening here? Talking about the speed of this person as he goes on this trip. So what is the maximum speed that he drives? 55, right.
Miles per hour.
And what's the minimum?
30.
Mm-hmm. Estimate the miles of highway with a speed limit of 55 miles per hour. In other words, how many miles do you think he drives at 55 miles per hour?
20.
What?
20.
20. Okay, so here's 4, right?
Right.
And then here's another 4. And
Oh,
then here's
so 12.
12, right. So about 12 probably.
Right.
Okay, so evaluate f of 4. What is f of 4?
40.
Yep, because that's where the solid dot is, right?
Mm-hmm.
And what is f of 12?
30.
30, because that's where the solid dot is. And what's f of 18?
I got 55.
Yep, because it's in that interval, right?
Well, at least some of this is starting to click.
Yeah, I mean, this is I don't know. I'm not a fan of this problem, to be honest. I know they're trying to give you like an application. But,
Yeah.
this is like one of those things that's only going to exist in your textbook, like, because that is not the way like acceleration would work. Like he's like literally going from 55 to 40 and like
Right. Yeah, no.
instantaneously, and that's not the way. Like this would be a smooth curve if it was actually realistically depicting what they're trying to depict.
Absolutely. Yeah, I know.
Kind of silly, but it works for what they're trying to show, right?
Right.
Okay, so this one says the graph shows a driver's distance from home after X hours. So what is f of 1.5? So that when the time is 1.5,
I was going to say 30.
yeah, it looks like 30 to me, or close enough. So f
Passing
of
in the middle.
1.5 is equal to 30 miles. Okay, and then what is f of 4?
10.
Yeah. Okay, so let's interpret the slope of each line segment. So this first line segment,
Over 2.
what's the slope?
I put 4 over 2.
It's 40 over 2. So,
Oh.
yeah. And what does that mean?
Let's see. 22.
It's 20, right? And so,
So
what?
4 over 1.
It's 40 over 2, right?
Right.
And so, and that's 20, but 20 what? How
Miles per
fast?
hour?
Right. That's how fast this guy's going for the first 2 hours. Okay, then here he's going, so he was going away, and also what is it in relationship to home? Is he getting further from home, or is he getting closer to here's his house right here. So is he getting further from home, or is he getting closer to home on this first 2 hours?
Further from home, the
He's
first part.
further, right? Okay. So now what's happening here is he is doing what?
U-turn is getting closer.
He's going back home, right? Okay, so
Yeah.
he goes back home. So what's the slope of this line right here?
Negative 20? Or
Negative what?
40? Or above another 10?
31.
Okay, so it's down 30, right? And
Right.
over 1. So it's going to be minus 30 over 1. Okay, so the slope, though, he's going 30 miles per hour, but he's coming back home, right? It's 30 miles per hour, but going back home. Okay, now he stops at, I don't know, Cracker Barrel or something right here, right? That's what's happening. So from
Do we have to write out the slopes exactly like that, or can we just put the 20 miles per hour for the first,
yeah, but the only problem I have with the slope, you can put negative 30, but it's not really it's not negative 30 miles per hour. He's going 30 miles per hour. He's just going. Matt,
Yes,
how do you?
when we talk about like miles per hour or like a rate like that, it's always going to be like positive, but the negative indicates the direction that you're going. So you have to tell me like 20 miles per hour, and like it should probably really say like 20 miles per hour away, and then like 30 miles per hour towards, right?
Right. Yeah, just make sure that you indicate what
what
direction.
direction he's going.
Right. All right, so then from 3 to 4, what's the slope and what does that mean?
Slope is 0. He stayed in the same place for an hour.
Right, exactly.
There's a Snapchat filter or something that will tell you your speed, and if you like take it, it always says 0 miles per hour if you're not in a car.
All right, finally he's on his last leg, last hour going home, and what's the slope?
Negative 10.
Okay, right. And so that means he's 10 miles per hour going towards home. All right, so here we are not going to ask you at this point anyway to graph piecewise functions that aren't linear. Right now we're just doing piecewise functions that are linear, but matching, you should be able to match. So because what does this guy look like? X squared minus 4. Just what general shape
going
is
over 4.
what?
It's like a parabola, but going over 4, like kind of like what B looks like.
It looks like this, right?
Right.
Okay, but look what it says, greater than or equal to 0. So let's say this is our graph. If x is greater than or equal to 0, what part of that graph would we pick?
The right-hand side.
The right-hand side, exactly. Oops.
Was this part of the assigned homework?
Yes,
Because we don't technically do this till later.
I know. Well, I think what they're trying to do is make them just recognize. I know. I thought the same thing because we're only doing linear stuff. But I think what they're wanting to do is recognize which one would this have to be if you saw a quadratic in the problem.
Wait, which question is this?
This is
33.
number
33.
33.
Right.
Yeah.
I mean, sometimes they like to go a little bit over in the homework too, to get them to think about things. I think sometimes.
Yeah. So which is the only one that this could possibly be, knowing that x squared minus 4 is a parabola?
B.
Graph B.
Graph B, right. So graph B, it's going to have to be, it can't be this one, it can't be this one, it can't be this one. Now, if the intervals that they gave you had like an absolute value, then you would have known to pick that one, okay? So just for grins, the negative x plus 5 when x is less than 0. So if you pick numbers that were less than 0, like -1, -2, -3, and I'm going to go ahead and pick 0 too, because, but we know it's less than 0, so that's going to be an open dot. So if I put 0 in there, I would get 5. If I put -1 in there, negative of -1 is 1, plus 5 is 6. If I put -2 in there, negative of -2 is 2, plus 5 is 7. Negative -3 is 3, plus 5 is 8. And if I plotted those points, this is what I would get right here. So it is B. All right, now this one, what does this look like? -4 if x is less than 0.
I got D for that one.
D, absolutely, it has to be D because it's two constants, right? So
Right.
-4 if x is less than 0, and +4 if x is greater than or equal to 0.
Well, that. Well, the way I'm sorry. No, I'm saying
Yeah.
the way I just look at the equal signs.
Mhm.
One has to be open and one has to be closed, and then I looked
Yep.
at intercepts, and there's only one that's on the Y's, like 4 and 4. That's just the way.
Yeah. So, and and the open one has to be the top one because it's got the less than.
Right.
I would
Okay.
be careful with that because if they overlap the open and the closed, then you won't see the open.
Yeah, kind of like how C is.
Yeah.
Yeah. That's just how I didn't know if that was good or not, but now I know. Appreciate it.
Well, we made it through the homework. It's with just a little bit overtime, but it's a pretty short homework assignment. Hopefully it'll give you a little more practice, or go back in and redo this one, especially graphing piecewise functions. I would recommend that you practice more on that. And y'all have a great weekend. And I'm going to hang in here, Matt.